to fit the data well, okay? In order to support this, what they want you to be able to do is to analyze the scatter plot. So to say what's happening to the points. It doesn't want you to just say it's waves. They're going up and down, okay? That is not the answer that they would be looking for. The answer would be based off of mathematical reasons. Why would this be a better fit? And the reason would be is that your scatter plot, right? So you'd be utilizing the scatter plot. Do I need a scatter plot 5 points, or can y'all see that they're increasing and going up and going down? Okay, so I'm going to just draw it because you can see that the values are going here, and then they're going to go up. And then if it's a wave, it's going to have to naturally do what? Come back down, right? So just analyzing, and it's using the terms of math. It wants you to be able to use math terms. So what our explanation here would be is the scatter plot. No, Ms. Jones is increasing. And there's a curve, which makes it concave up. Perfect. Oh, really? Well, good guess. It's concaved up.
Oh, yeah.
Mm-hmm. Would it not be? Would it not be? The way. Mm-hmm.
Wait, but since it's concave up, yeah.
This is true. Yep. That's true.
No,
it's true. I didn't think that hard. No, I'm playing. Let's see. We'll just analyze it. We'll do it. Stat, edit. It's really quick. Type in. I know I reset you. Did I not press all the buttons? Second plus. Second plus 7, 1, 2. I'll do it really quick. 3, 5, 7, 8, and 10. Yeah, we're just gonna look at the curves. Did you say that we're doing baby stats right now, Oscar?
He did say that.
We are. We are doing baby stats.
It's for people like Alberta.
I didn't say that part, but we are doing baby stats. All right, I'm going to go ahead and turn on the plot. And I'm going to go to Zoom so I can look at the data. Do you see it now? The scatter plot, and it's doing what? So it's curved up, which means, like you all said, it technically could be what? Exponential, okay? But that's also assuming that at no point does it ever stop. Like there's no point. So I guess it's more of using a little bit of common sense of what naturally the waves are going to do. I think would be, but technically, yeah, exponential or quadratic. So if I ran stat calc, I'm going to run a quadratic model, 5. And I'm going to store that as my y1. And then I'm going to run I did not press quadratic, and y'all didn't tell me that. I think my computer went back to sleep. Okay, again, alpha trace. This is going to be my 1. And we're going to look at, there's quadratic. And then we're going to do it again, but this time we're going to do exponential. Stat calc and exponential is 9. Stat calc, not 9, 0. And this time I'm going to store it as y2 so that we can see both graphs. And hit calculate. And now here's my quadratic coming in. It looks pretty darn quadratic there.
Wait, how do you
and then here is my exponential coming in. And what do you notice on the exponential? It's a little less accurate. It's not growing as rapidly as an exponential would be growing. Do you see the difference? Okay, so we can clearly see why it's more quadratic than exponential. Yes? We're confident now? All right. Yes.
How'd you get this blocks in the red one again?
The blocks, I went to Zoom, see my stats. So Zoom 9.
Oh.
After our turn. Or turn. Did you turn on your plot?
Now I did.
Okay. All right. So continue with our explanation. So now it says, what is your equation? Well, we're looking for the equation of the quadratic. Because I stored it, even if I closed it out, can I easily go find my equation? Yes. So just because I closed it out doesn't mean anything. So we got y hat. The reason why, again, when we're using a hat is because this is a regression. It is what we're using for prediction. Y hat equals, and I'm going to round to the nearest 3 decimal places. So 747 thousandths x squared. I'm going to scroll over. Minus 1 and 231 thousandths x. Scroll over some more. Keep scrolling.
How'd you get the other equation?
Exponential. I did an exponential regression. Plus 3.040. All right, how do you feel? Yeah. Okay. You can also do a residual plot with a quadratic. However, you can't run a residual plot when there's 2 data sets in here, so you would have to delete out the exponential. So I would have to delete out the exponential. But I would go through the same thing of going to plot 2. So second, y equals. I'm going to go to plot 2. And instead of L2, we want to change it to residual. How do I get to the residual? Second step. And you see 7, or mainly look for RESID. Hit enter. And I'm going to have to re-zoom my statistics. So I go to zoom. And I'm going to go to 9 for zoom stats. Did I still not turn it on? Thank you for letting me. Stop graphing. Stop it. We're going to go here. What? You saw nothing. It was on. There it is. And that's a pretty good. Almost all points are on the line except 1. Yes? Doable? And that's what it would be analyzing your residual. So the residuals, your errors, are closely aligned on the x-axis. And are good to go. All right?
Get that? The upside down. How did you
Get what?
How did you get upside down?
What upside down? The points? My residuals? I went to plot 2 and turned in my residuals. All right, so as you can see, this is just going through the model and trying and just getting used to regression models and analyzing what they look like or which one best fits with using their residual pattern. Again, when you're doing this, in order to analyze residuals, you can't have them all in your Y at the same time. Does that make sense? So if I'm going to do Y, if I do the quadratic model, I then have to go look at the residual for the quadratic. Then I can do the exponential model and then look at the residual model for the exponential, then do the power model, then look at it. Does that make sense? Oh yeah. So on C, it just basically was saying, how do your residual plots look? So they are close to the x-axis. Yes. Residuals are close to positive x-axis. Sorry, I said it out loud, but I didn't write it.
So for some reason, when I checked with the plot 2, the blue squares on the plot 1 were turned red.
I would have to look. I don't know exactly what you did, but I would have to look. All right, so we're going to do the power model, but for this one, I did want to not use the graph calculator. I just wanted to review Desmos with you. Is that okay? We're not going to go through the whole thing as far as in the calculator. But I think this will be like a good stopping point, but I just want to make sure to go through Desmos with you for the ones who do want to be comfortable with Desmos. Is that cool? All right, so I'm going to switch gears to Desmos, and then we're going to talk about how Desmos sometimes is a lot friendlier, a lot easier to use for certain things, okay? All right, so switching gears to handy dandy Desmos. You either can follow along, or if you're pretty confident with the TI-84, you honestly don't need the Desmos, but it is there to show you do have a friend. All right. Here is my Desmos. The first thing I'm going to do is input the table. So to add the table, I click on the plus sign, and I'm going to go to table. I'm going to put in my X values. So I have 1, 6. It'll be nice if I type. And I love how y'all just be sitting here letting me thinking I'm doing stuff, and no one says, Miss Jones, you're not doing anything. What'd you say? Is it an emergency? Yeah. 6, 14, 25, 27, 31, 33, 38, 42. All right, then on my Y ones, 0.2, 0.55, 1.1, 2.9, 3.8, 8 point what? 0.2, 9.3, 10.6, 15.7. All right, so I have my points in. I'm going to click this little magnifying glass here, and it's going to show me my values. There are my points, okay? Now I'm going to find the regression models. So I'm going to start off with quadratic. So I'm going to go here in Y2, and I'm going to type in for quadratic. That's Y1 tilde AX1 shift 6 to square plus BX1 plus C. Okay, so from there, I then can now write down what it says my equation would be, right? So rounding to the nearest 3 decimal places, it would be Y equals 0.1305. You see what I'm saying? Yes, right? Now, I will give it to Desmos. Its residual plot is way easier to find because you just literally press plot. So you see where it says plot? You just press it, and there's your residual. So now you have your residual plot. So you analyze your residual plot. Is it randomly scattered? Yeah, it's randomly scattered above and below the x-axis. Is this a good model? Yeah, it's not a bad model at all, right? Easy enough? Okay. All right. So then you want to test out an exponential. You don't have to delete it. You can zoom in on it. That's what that feature is there for. Next, to do the exponential, we would have Y1 tilde, and it's AB shift 6 X1. Okay, what did I tell you in the beginning? We need to make sure what is checked? The log box. We want to make sure that this is checked. Now, to me, it becomes a lot of data on one screen. So I would delete that because it bothered me. So here's the data. I don't know. I just delete it. You probably can hide it. Yeah, and does this and it takes it all away. Yeah, I know. But I delete it. Because then the scatter plot's still there, or does it take it away too? Does your residual stay? Yeah. So here is now my residual plot for my exponential. It is also randomly scattered, which means that this is also a fairly good model that I could use for this. Notice that it also has more points that are on the positive x-axis. So it may even be a better model. And I can write down the equation. I have my A is 0.239, and my B would be 1.12. Yeah. Or however you want to round, or 1.1099 if you want to be better exact. But that would be the power function. Okay. All right, the next model that I don't know how to do just a generic power function in what's this thing called? Um in Desmos, like in TI-84, we have the power button. I'm going to show you what I mean so that you can maybe you'll figure it out, but I can yet figure out how to do it. So I challenge you. But in here, when we run a model, we have the option of stat calc. And if we scroll, I'm going to go up just to go to it faster. You see where it says power reg? That's a power regression. So it's going to run through and tell you what's the best fit, whether it's a quadratic, a cubic, a quartic. It's going to run through that, but I don't know how to do that in Desmos. So I will challenge you to do that in Desmos. Yeah, I'm honest. I'm honest. You want to be a liar? And so my thought is, I'm sure that if I write the same model, it should work, but I've never ran a power function in Desmos, and I'm not going to pretend today that I have. Why? Because you know how much I believe in Sylvie and all of Sylvie's children. So I typically just don't do things that are going to abandon her, okay? But I'm pretty sure it's just AX1 and then to the B, and I'll run it. I'm going to assume that's what it is. It makes sense in my brain. How accurate it is, I don't know, but it could be wrong, and it may not work. But that's the best I got for you on this situation.
That is the impression of
Yeah, and again, make sure you check the what box, the log.
this one.
Anytime there's a log box, we want to make sure we do what? Check it. All right, so I'm thinking that this is when it asks you, so on your notes, this is what's the power model. I'm going to assume in Desmos that this is what it means. And it looks like, yeah, it is, because this is what I got in TI-84 as well. But there will be your power model is just simply the AX1 to the B. You're saying, hey, Desmos, figure out what type of model would best represent this. And so then now when you analyze your residual plot, so I'm going to turn on the plot so you can see it. Notice that it seems to be concaving up, right? So there's a clear pattern to my residual model, which is telling me that this is probably either a exponential. You see the kind of curve? You see it? Yeah. Looking at the residual plot.